Hello everyone. Let us now discuss how can we solve this problem. Count the number of good subarrays. So the question description is something like given with nums array and an integer k, return the number of good subarrays of nums. Now a subarray is good if there are at least k pairs. They mentioned that at least k pairs, not exactly. So it can be k pairs or k plus 1, k plus 2. If k is 2, then we can get 2 pairs. Then we can also consider 3 pairs, 4 pairs, and so on. But at least k, that means we need in the subarray at least 2 pairs if k is equal to 2. It can be 3 pairs also, it can be considered of indices I comma j such that I is less than j and array of I is equal to array of j. A subarray is a contiguous non-empty subsequence of elements within an array. So if we see here 11111 and k is equal to 10. Now the only subarray is the array nums itself. Why? Because this is one uh, subarray, right? This is one subarray, and then this is another subarray, and so on, right? This is another one, and this is another one. And if I take this as another subarray, this as another subarray, so there are 10 subarrays, right? Now I have another example like 314324 and k is equal to 2. Let us see what are the number of good subarrays here. So I am taking something like just a subarray, right? Just taking one element as a subarray. So I am taking only this element as subarray. Now let us see 3 is occurred for till now how many times? Now only till now how many times? 0 times. Now when I go here, then my 3 will be incremented. So not before going to the right. Now, only after something like before going to the right, I won't increment the count. Only after going to the right, then only I'll increment. I'll tell you how. Or after checking only, I'll increment the count. Now, 1, how many times I have seen 1? 0 times. Now, I have gone to 4, but before going to 4, 1 is present for 1 time. Now 4 is present for how many times? 0 times. Why I am checking it? I'll tell you in a few seconds. Now I have 3, right? Okay, I have 3. Do I have a 3 before? Yes. How many times? Just 1 time. So the number of pairs that I can get, how many pairs? I can get 1 pair with 3. Why? Why? Because when I get to this 3, I know that previously I have 1 3. So this 3 with this 1 can make 1 pair. So that's why I will check whether I have this element before. So if I have this element before like just 1 time, then how many times I have that element, then I'll increment that into pairs. Now I only got pairs. I didn't get the answer of good subarrays. I'll tell you how I can get the count of good subarrays in a few seconds. Now I am going to write, but how many pairs, how many times 3 I got till now? It's not 1, it's 2, right? Now I have 2. Do I have a 2 here? No. 2 is for 0 times. So sorry, I have forgotten to increment the count of 4. Sorry for this mistake. So 4 is present for 1 time. Now 2 is 0 times. Now I am going to 2, but before that I'll increment 2 for 1 time. Then I'll get 2 is present for 1 time. Okay. Now I went to the right. Now I went to the right. Now I have a 2. I'll check again in this something like a hash map or dictionary in Python. 2 is present for how many times? 1 time. So what does this mean? That means when I get here a 2 and 2 is already present before in the array and I have the count as 1, that means with this 2 I can make a pair, this 2 and this 2, and also previously I can make a pair with this 3 and also this 3. Now without being confused with the 3, I just got a pair with 3 and this 3. Now, I have a 2 before and I got a 2 here. So, I have 1, 2 before. So, the number of pairs is the count of 2. I'll tell you why I am incrementing pairs plus is equal to frequency of nums of r, frequency of nums of r, or I, you can say it as I, but we are using like left and right. I'll tell you why we are choosing left and right in a few seconds. Now frequency is nothing but this hash map, frequency is nothing but this hash map. Right now pairs are increased to 2. Let me tell you that yes, because here I have 3 and 3. This is one pair. 3 3 is one pair. 2 2 is another pair. So totally I have two pairs. Now 2 is present for how many times? 2 times. Okay, I have incremented and then I am going to 4. Now, so before going to 4, but let me say that here till now I have pairs 2. Now let us see that let me say that here I am doing something like a copy of this array, right? Okay, I need k is equal to k is equal to 2. That means I need two pairs in the subarray, right? I have till now, till this, so I am writing that till this I got two pairs. Okay, now what I am doing is placing some more elements at the right. 1 2 4 5 6 7 8 9. Now let us see that here let me say that here till now, let me say here till now I got two pairs. This is one pair and this is another pair. Okay, I got two pairs. What they asked for, at least k pairs, at least k pairs. Now I have two pairs. It doesn't matter if this subarray is included. This subarray is already included. Okay, this subarray is included, but if this subarray, if we take this, even then I got 1 and 1 is also another subarray, but no matter, at least k subarrays, k pairs, right? Here we got 3 pairs, right? No need to worry. Even if we got more than k pairs, we are already asked with at least k pairs, so this subarray can also be included. Now, can we include this subarray, whole subarray? Okay, it's perfectly alright. Can we include from here to here? Okay, it's perfectly alright. Then here to here, then here to here, then here to here. No matter what are the pairs I am getting, I am just adding here and then here. Oh, sorry, here and then here to here. So totally how many subarrays did I get here? Let me remove all these things. Wait a second. So just till here, I think, yes, till here it was totally two pairs, exactly k pairs. Now one, this is one subarray, this is second subarray. That means till this is second subarray, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So I'll give you something like indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12, and then 13, and then 14. Okay, I got k pairs at index 5. Totally I got 10 subarrays, right? So totally I'll get n minus r. 15 minus 5, right? 15 minus 5 have given me 10 subarrays. So totally I have 10 subarrays. That's it. So when I am writing this intuition here. When I get k or greater than k pairs, then answer is, that means number of subarrays. Number of good subarrays is is n minus r. Okay, that's it. Now, why I said that greater than k, right? When even if it is greater than k, why are you saying that it is a good summary? Let me tell you that again, that taking this summary, I am just don't consider this summary, it is so long, but take this as an example. Imagine I have started here, right? The L or my window or the subarray till now is just starting here. Now I have ended here, right? Yes. How many subarrays that I can get? Good subarrays. Why? Because this one and this one make a pair. So totally one pair till now, right? This two and this two is creating another pair. So totally how many pairs? Two pairs. That means here we are given with k is equal to 2. So what are the good subarrays? Even I can get this, even I can get by adding or including this element to the subarray, this one, and then this. So that's why even when greater than k pairs I get, then also the number of good subarrays is n minus r. This is the whole intuition to get total number of good subarrays. But I am confusing. This is the most problem in sliding window, that when to grow or and when to shrink the sliding window. Okay, I got a window with left and right. When I need to grow and when I need to shrink, and when I need to stop the growing of the sliding window. Let me say that. Here whenever I get more than or equal equal to k pairs, then stop expanding or stop growing and start shrinking. Okay, okay. And this growing is something like growing is done with growing is done with something like r pointer, right? Okay, right. So right will be incremented every time, but it will be stopped when the number of pairs are greater than or equal to k. I'll tell you why and how. Okay, here I am taking this array. Just I have changed a 3 here, that means I have added a 3 here. So till now I have zero sub pairs. Till now zero pairs. Now I have one pair. Okay, I have pairs is equal to 1. Okay, now here I got how many pairs? 2 pairs. Why? Why? Because here I have this as one pair, and also this and this makes another pair. But if you see, this and also this makes a pair, right? So how many pairs do I have exactly? So that's why I'll do something like a dry run for this. So till now 3 is present for, I am just considering 3. 3 is present for 2 times. Now when I am going here, so let me go till here only, right? So that you will understand. 3 1 4, 3 is present for only one time. Now number of pairs is just 0 till now, but when I get here, 3 is already present in this hash map for one time. So that means this 3 can make a pair with this 3. So increment by 1. Now 3 is present for how many times? 2 times, right? Go to the next 3. Yes, I got a 3 and I have a 3 here already. So what does this mean is with this 3 I can make 2 pairs, right? So with this 3 I can make a pair. With this 3 I can make a pair. That's why I said to increment the pairs with the count of nums of R. That's it. So if I add 2, that means frequency of 3, then I'll get the number of pairs as 3. Okay, that's it for this question, that we are adding the pair. That's it, right? Now I'll just write the algorithm here, so then you can understand how I am going. Just left is equal to 0, right is equal to 0, pairs is equal to 0, and I have hash map, and you can use a dictionary in Python if you are a Python user. Now hash map is used. Now what is something like while r is less than n and n is nums dot size. Okay, while r is less than n, as I said, I will check for the nums of R frequency and add it to pairs, number of pairs. So pairs plus is equal to frequency of, and hash map, let me name it as frequency. Pairs plus is equal to nums of R. Okay. Now after adding this, I am saying that nums of frequency of nums of R plus plus. As I said, after checking whether I have a 3, whether I have a 2, uh, that means nums of R, whether I have a nums of R, then only after adding it to the pairs, then I am incrementing the count of nums of R. Okay, frequency of nums of R is incremented. Then I am incrementing frequency of nums of R plus plus. So here comes the shrinking part. So while pairs are greater than or is equal to k, I'll do something like frequency of nums of L minus minus and L plus plus, but before that pairs are decremented by frequency of nums of L. So after this, I'll increment R plus plus. So this is how we solve this problem. But if you didn't understand this algorithm, let me do a dry run here. So here we are growing our sliding window here. So after R plus plus, but before that here answer plus is equal to n minus R. As I said, I will add all those subarrays which are even having more than case pairs, right? So at the last we'll return our answer. Okay, let us do a dry run by taking this algorithm. Now I have the same example given in the description. Okay, what are all those things that I need to initialize? L is equal to 0. L is equal to 0. Okay, L is equal to 0 and R is equal to 0, and I have a hash map, an empty hash map of frequency. Okay, now answer is also equal to 0, and also the pairs is also equal to 0. Now I have k is equal to 2. Now R is less than n. Is it true? Yes. N is 7. So the size of array is 7. Now pairs plus is equal to frequency of nums of R. R is 0, nums of R is 3. So that means 3 is having by default a frequency of 0 in hash map. So frequency of nums of R plus plus, then 3 is having a frequency of 1. Now, while pairs is greater than or equal to k, pairs is just 0. It is not greater than or equal to 2. So skip that. R plus plus, R is incremented by 1. So R becomes 1. Now, pairs plus is equal to frequency of nums of R. R is 1, nums of R is 1. So pairs is not incremented as 1 is having 0 frequency. Frequency of nums of R plus plus, so 1 is incremented. The frequency of 1 is incremented by 1. Okay, now while pairs is greater than or equal to k, false. R plus plus, so I am incrementing R by 1, then I'll get 2. 4 is nums of r. Do I have a 4 here? Pairs plus is equal to frequency of nums of r. 4 is having a 0 frequency. So pairs is still having 0 frequency of nums of r plus plus. So 4 is incremented by 1. Okay. Now, while pairs are greater than or equal to k, false. R plus plus R is becoming 3 now. So I have here 3. Now, do I have pairs plus is equal to frequency of nums of R? Frequency of nums of R is 1. 3 is having a frequency of 1. So pairs are incremented by 1. Then I will get 1 as number of pairs. Okay. Now do so frequency of nums of r plus plus. So 3 is incremented. The frequency of 3 is incremented by 1. Then I'll get 2. Now while pairs is greater than or equal to k. No, false. R plus plus. R is becoming 4 now. 4 now. Now pairs plus is equal to frequency of nums of r. Here I have a 2. Do I have a 2 before in the hash map? No. Frequency of nums of r plus plus 2 is incremented by 1. Okay. Now here frequency of nums of r incremented. Pairs is greater than or equal to k. False. R plus plus going r to 5. Okay. Now I have 2 here. Frequency of nums of r 2 is having 1. So pairs plus is equal to frequency of nums of r. So total number of pairs I have is 2. Frequency of nums of r is incremented. Then I'll get 2 for frequency of 2. Now pairs is greater than or equal to k. Pairs are 2 which is equal to k. So this will be executed. Answer plus is equal to n minus r. 7 minus 5 will give you 2. That's it. Here we are getting 2 as the answer as total number of subarrays you can get till here. So this is the use of sliding window without using any force. Frequency of nums of L minus minus. L is 0 till now. So nums of L is 3. So I am decrementing by 1. Then 3 will be frequency of 3 will be 1. Pairs minus is equal to frequency of nums of L. So pairs is having 2. Now frequency of nums of L is 1. That means I am decrementing this pair will be absent, right? So this pair will not be in our sliding window as we are shrinking our sliding window. So pairs will be decremented by 1. Then I'll get pairs as 1. Nums L plus plus. So here our sliding window is having L is equal to 1. Okay, perfectly all right till now. Pairs are greater than or is equal to 1. No, k is equal to 2 and pairs is just 1. So out of the loop and r plus plus. So if I increment my r will be 6. Okay, I am at this index, right? 4. Pairs plus is equal to frequency of nums of r. So 4 is present for one time. So pairs is incremented by 1. Then I'll get 2. Okay, frequency of nums of r plus plus 4 is present for 2 times. So I am incrementing the frequency of 4. Then while pairs are greater than or equal to k. So this will be executed as pairs is equal to 2. Answer plus is equal to n minus r. Okay. R is equal to 6, right? And N is equal to 7. 7 minus 6 is 1. So if I increment my answer by 1, then I will get 3 as the answer. Total number of subarrays, good subarrays, I have 3 right now. Now, I have frequency of nums of L minus minus. That means I am decrementing 1 frequency of 1 by 1. Okay. I am decrementing frequency of nums by 1. Then I'll get 0. So simply let me erase it. Simply let me erase it. Even if I don't erase, there is no problem. Now, pairs minus is equal to frequency of nums of L. There is no decrement, right? It is just 0. So pairs are just 2. Pairs minus is equal to frequency of nums of L. Okay. Now L plus plus. So L is becoming 2 now. L is becoming 2 now. Let me remove this. Okay. Now here pairs is it greater than or equal to 2? Yes, it is greater than or equal to 2. Now answer plus is equal to n minus r. 7 minus 6 is 1. So I have totally 4 pairs. This is also a valid pair. So this is how you solve this problem, and this will be continuing 3. It will become 3, 4, 5, 6, and it will stop here. So this is how the diagram works. If you like this video, do share to your friends and to subscribe to my channel. And this is the code. I have given the code link in the description. Thank you.